All right. So welcome everyone. So nice to be here for the first time in Moldova. Thanks also for the colleagues for the warm welcome. I'm Simon. Here's Maksym, and today we're going to present, as the introduction said, how we team up for legacy code migration. So about us, besides the warm introduction from Dennis and Veronica, I'm big data and AI architect in Grid Dynamics. Also, I've performed some public speeches in AI and mostly big data in Krakow and in general in Poland. And Maksym is really active engineer and architect in our blog posts. Okay, so we go through our agenda. What we are going to talk today. So an introduction about Agentic AI, how we use it with MCPs and other integrations, a quick intro to how we integrate with the RAG, just for not only for who doesn't know RAG, but also in order to give a connection to what we are actually building with our agents. An introduction to a framework that allows us to build agents that is Pydantic AI, and then we move to the concrete agents that we build and how we leverage them in order to have a sort of assistant or a group of assistants that help us to perform the whole software development lifecycle. Okay, so what is Agentic AI? Agentic AI, for who doesn't know, it refers to an AI system that is capable to perform autonomous actions. How these autonomous actions are performed is like we can call it like a sort of like continuous loop of invoking an LLM agent, LLM endpoint, performing some tool calls, and adapt to each step. So here we can see there are majority of the flows goes with the thought, action, checking, then again in loop with some sort of control. Two controls that we can see here are human and guardrails. Why we need these two? One is a sort of first control, like you don't allow, especially for a cost perspective, not only for a risk, to make everything going through. And the second one, someone still needs to check if everything is going in the right direction. So how we put the agents in a sort of a matrix? We can put it from the verticals and from the horizontals. So we can see that agents can be of multiple type. So we can have agents that work with plan and execute, also known as react or plan act. We can have multiple agents workflows. So different patterns can be one after the other, can be one, then few in parallel, then collect again, or can be even a round robin. Just let one agent to perform a scan, then pick the next one, then wait for the result, call another one, and be autonomous. And then there are the last two that are pretty crucial, especially in our scenarios. One is called agent as a judge, and the other is the concept of agent meshes. Agent as a judge, as the name says, is basically it's a sort of like team leader or a sort of like reviewer of your work. So every time the agent is about to make some sort of actions that need some review, instead of having every time a person that is right in front and say like, yes, it's correct, no, it's wrong, you just make it autonomous. So like your teammates, like, hey, what do you think? Should I call this variable X or Y? No, give a proper name, please. That would be an example. Or the agent meshes. So agent meshes is like an app store, let's say. So you make a marketplace of available agents. Sometimes you can find it referred as agent canvas. So what it means is that in some organizations, in one of our clients, for example, I can make this reference, we didn't want to have one UI for one agent, one UI for another, or one endpoint for one agent, one endpoint for another. We just wanted to say like, hey, I have Microsoft Teams, and my people use only and exclusive Microsoft Teams. So how can we make just one endpoint and then let the backend choose which agent should react. So how this one works, you have a marketplace, you have all the catalog with descriptions, cards, and skills, and then you basically pick every time who can be potentially the best candidate from these meshes. And between them internally, then they can talk. Like you decide if you want to go from the front door or from the back door, and then after that, you are in the 12th floor and you start to speak with your GitHub expert, your Java expert, big data expert, business analyst, architect, and so on. So this is the concept in this case. From the horizontal side, basically where we can apply AI, we can consider everything or nearly everything, from everything that requires only software, but can be also software and hardware, or as some other colossal of technology showed, can be even just hardware, potentially. Max, you want to add something on this slide? All right, I will pass the word to Max now to give a short introduction to RAG.
Okay, guys, let's refresh in our memory what is actually RAG. I prepared a couple of schemas for you. So the simple RAG, first we're starting with the request. So we have to take the request from the user or whatever it should be. Like it could be not user request, it could be Jira ticket as a request as we see in the demo. So we're preparing the vector and then we're searching this close vectors, close data in our vector DB and preparing some chunks. Like we are getting the data from the vector DB, like the chunks. We will talk about the chunks later. So, and then those chunks will be used, like there we are passing the chunks, the text chunks to the LLM, as well as the request, if you see on the picture. And then LLM returns us some answer already generated and generation already based on data we provided from the vector DB. So yeah, it may give you some answers or give you some stuff not related to the text from the chunks, like data from the internet. So, but there are some ways how you can fight, but mostly this is about the generating answers based on the text or like based on the data from the vector DB. I have another schema. This is the RAG with the reranker, a little bit more complicated, but also idea the same. So what does reranker? Reranker just checking your initial chunks and making rerank. As you see, you can just get 10 chunks and then maybe rerank them, maybe reshuffle, remove redundant, whatever. So it the schema with the reranker. Yeah, we had to talk a lot about the chunks, but let's see what is actually the chunk. So chunk, this is the piece of text limited by amount of the characters. You're specifying the amount of the characters when you are configuring your vector DB. So in my case, I'll show you how it is, but in my case on our demo, it would be 500 something. Also what we have metadata, like the document name, URL, heading, data, whatever you want to put there, it could be there. Also, you can do this cheat. You can add additional chunks, that they're context chunks. So if you found in your vector database chunk that matches your initial query with like 89%. So, but you want to have extra, like let's say your chunks divided not in a convenient way, because chunkization, this is different, complicated task, and it may take, a couple of hours to discuss how we can chunkize, make the chunks, because, when we are preparing the chunks, you're just trying not to split them, meaning you're trying not to break the sentence, so on, so on. So yeah, for this, we can use the context chunks that's connecting the neighbor chunks. Yeah, and yeah, one last slide from me about the chunks and the RAG. This is the how chunk actually appeared in the vector database. So to load your chunk, you already have some documents, like your chunks prepared like with the text as a text. You need to use some embedding model. It could be used different. You can find open source models. I'll show you today one open source model that you can use for your projects. as well as you can use some commercial models like OpenAI. So then you're taking embeddings, you're creating the vector DB using the embedding models, embedding model, just putting the chunks. Like I tried to specify different colors, and they, as you see, they're like, the same color, they're close to each other. Which means that they're close according to the topic. Let's say this chunk's about the cats, this chunk's about the dogs. So, and they're different, but if you're looking the data about the cats, they're somewhere in the same place, and embedding model knows where they are. Yeah, and let's talk about the MCP. Boss?
Okay. Are you able to hear me in this way? Okay. So now we had described one of the most critical part of AI systems, that is the retrieval, right? So in RAG, most of the time the issues can be, as Maksym said, how to create the knowledge. So how you index it, how you're retrieving. And most of the time the clients say like, the LLMs don't respond correctly, or it hallucinates, And it's like, yeah, but it's not, can be that is not actually the LLM all the time. So a lot of times it happens also that you need to pick a different source of your data. Now, I don't know how many of you heard about or played with MCP before. Can you raise your hand more or less, like who played with MCPs before? Okay, so you notice that there are tons of MCPs that are written in completely different languages. There are some that are written with Go, some that with Python, just some with TypeScript and so on. And imagine if you have to make classic boilerplate applications. Every time you think, oh, I want to use this API, damn it, is only in Python, but I'm writing TypeScript. And some other are written with Go and so on and so forth. With MCP, you basically have a one single universal connection. And this will allow you, as in the slides you can see, to connect agents that are built in different languages with tools that are written in different languages, interfacing with endpoints that can be written in I don't care which language. So how you then connect is just one single tunnel that allow you to talk with your brain, interact with your connectors, and then make everything looks like, oh, it's so easy, I can do it in 1 week. So this is where the MCP protocol made by Anthropic, made available for everyone, is getting so much popularity, because then you can focus on what is on the beginning, what is on the right-hand side, in between is just one configuration. So in this case, let's say that we are the team, me and Maksym. Maksym is focusing a lot on the context creation with chunks and so on. We just take the MCP, connect it, and maybe I'm writing Python. He would prefer to write it in TypeScript because he likes it more. Perfect, be my guest. I don't mind. After that, there will be someone writing in Scala because maybe they want to do something more fancy with JVM technologies. They will just connect to that. Now, connected to that, most of us use Cursor, Claude, Gemini, and more and more and more are appearing, right? How those are connected? Want to go?
Yeah, okay.
He's the expert of our vibe coding, so.
Vibe coder. Okay, yeah. So you have most probably you have a Cursor or Claude Code or any other tool that supports the MCP. So the MCP, this is kind of standard, as Simon mentioned. This is kind of Type C in the world of coding. So here on the board, or there on the board, you have MCP host and MCP client. So to run any like MCP third party, to connect third party tools like Drive, Figma, Jira, or like whatever, last time I checked how much MCPs actually created, and you can find like more than 6,000 MCPs right now on the market. You can download from GitHub and use. So they just exchanging standard requests. So your client talking to your server that you are running locally. Maybe you can deploy the server somewhere to the cloud if you want for some reason. And then this server already talking to third-party tools like Drive, Figma, so on. Yeah, sorry, wrong laptop. Okay, yeah, the one image about actually what is the difference between the A2A. This is agent, which is from the Terminator. This how to call that guy, that T3000, right? T3000. This is my agents. So the agents actually, they're manipulating with the third-party tools using the MCP, but to communicate between each other, most probably they have to use protocol, some kind of A2A introduced by Google. So this is the difference between the A2A and MCP.
Before maybe moving to this one, there is one important point. Here we mark the slide as optional for one specific reason. It's really important to understand how you divide your agent group or agent team, because if you read some white papers and so on, they will tell you to not overload one agent with multiple tools. It will downgrade a lot the performances, make a lot of mistakes. That's why with the A2A protocol, you can basically create more agents that will perform the same, but with more accuracy and better debugging skills. But why optional? Not everything can be solved or needs to be solved with multiple agents. So here is where the AI engineering part needs to be skilled up, because you need to understand, do I really need to make an agent for this scope and then make it communicate via A2A, or I can just make an application that does it? So that is a really important point that needs to be considered before making agents, MCPs, A2A protocols, and so on.
Thank you for the clarification. And I want to share with you some tips and tricks about the MCPs. So if you want to install some MCP, you know where it is, you downloaded some, you know the link to that MCP, you can ask your AI agent to download it, easy and configure, so you don't need to do it manually, check out, so on. So very convenient. I highlighted the S, like, you know, this joke that S in MCP stands for the security. And I want to highlight, and we're telling to everyone in our company that before using some weird MCP, some custom created, just double check that they're not sending information to the third party. So, you know, instead of connecting to your Jira, it could connect, you know, store your data somewhere else. So yeah, it could be the big security breach to your system. You know, it may lead to potential data leak. Don't use too much MCPs, so because you're overloading, as Simon mentioned, you're overloading your AI agent. If you have 300 tools, AI agent confusing, it may use the wrong tool. So ask to use particular if you like, just for the case, if you have some, you're running a lot of MCP servers locally, I don't know, Playwright, Jira, database, and so on and so forth. So just ask to use some specific, ask to use dbMCP to connect to database and tell me what is the table describes this or that. Yeah, and I encourage you to use rules supported by most of the tools. Is it Cursor, Claude Code, and like most of the tools there support rules. So just specify rules that's like, if I'm requesting to do something with the database, most probably I want to use the MCP, like MCP database. Remember that AI still works bad with the negative context. So like the bad example of the bad rule, do not add comments on Russian language, or do not add comments on Italian language. So better to say add comments only in English. So like this part, don't do something, it could be ignored by your agent at all. Yeah, and passing word to you.
All right, so let's move now to a more concrete implementation. So you know, there are tons of frameworks to make agents. Some of them are really fast to start with, but they are not the best for production purpose. Some of them are really good for making a quick prototype. They can be used in production, but they have some hidden limitations that when you figure out, it's too late. And some others that are in between. So Pydantic AI is one framework that I think I discovered when it was at the version 0.9 or something. And I was like, okay, what is the difference between other frameworks that make agent and Pydantic AI? Everyone that worked with Python at least once in a more enterprise level heard about Pydantic or the data classes, but Pydantic is always there. Now, what if when you create basically a simple data class object, you can make it also for agents and make it like serializable, transferable, easy to move, to parse, and to make it passing across different platforms. Pydantic AI is, first of all, a type safe. So you don't need to deal with JSONs, with YMLs, so that some frameworks that I'm not going to mention do and force you to do. The other point is you can, as I said, validate and serialize, and it enforces you to use schema validations. So especially when you have agent meshes, you want to be sure that this agent receive and provides output and input in a format that you know will work. With other frameworks, you need to make the LLM accept an output, find the JSON, find the signature, and so on. With Pydantic AI, you just make the object be transferred. So the main control is over the JSON structure, or can be other structures if you want to go through, but JSON is the most common. And this allows to have a good and controlled communication between user and agent and intra-agents. Okay, we take now a quick QA break, so feel free to raise your hand and ask any question. Yes.
Question about the NCPs. Do you think it could be a bottleneck? Like, let's assume we have a very performant, safe, like all service. Would this MCP do you see any risk of the MCP performance? So can it become a problem?
Sure. Let me repeat the question.
Is it scalable or not?
Sure. So the question was, what are the bottlenecks or the limitations that we envision in applying MCP to our applications? Did I get it right?
Yeah.
Yeah. You want to get it? I want to get it.
I can add some.
Okay. Yes, we see some limitations. Doesn't mean that they cannot be solved by yourself or by the provider. The security, Maksym, that mentioned, is something that you need to keep in consideration all the time. From the scalability, I believe that if your MCP server is sort of like stateless, in that case, with the streamable HTTP, technically you can solve this issue. If it's a streamable STDIO, there might be a bit problematic. SSA I don't consider. It lasted just a few months, then they deprecated it and said, like, guys, no, we're not gonna use that. And apart from that, yes, the other point that I would consider is, he mentioned the amount of tools. Don't give like huge amount of capabilities. And the other point is about basically like the reliability on the action. So if you're gonna use some external one and you bring it in your organization, well, you're basically open the key potentially to any thief and say, like, please, this is my house, do whatever you want.
I want to contribute to this topic about the MCPs. So yeah, if you're using third-party MCP, this is not official MCP, let's say not official Jira MCP, and Atlassian will change their API. So those guys who are maintaining this MCP, the custom MCP, they may not update, they may not update the API, so it may not happen straight away. This is the first. The second, I'll show in my demo. I'm not using in my demo MCP because if you can avoid using MCP, better avoid to using MCP, right? So better to create because it's like in terms of the security, of course, and in terms of the performance, in terms of the performance. So, you have this additional layer of MCP, then AI thinking, okay, maybe I need to call this like Confluence request, or like I have to search something. So, you know, sometimes it's better to and faster to call API directly. Yeah, thank you for the question.
AI usually are expensive. Okay. Sure, I can. Actually, this is one of the topics where we are most of the times involved. Now, actually, yesterday there was an interesting article about how the AI cost control is getting on a second level. Like a lot of companies that just say, we want AI. And we want to just use it. We don't care how much it will be my billing. I want like the latest OpenAI, the latest Claude, Opus, Gemini 3 thinking. 3 months later, they call us and say like, we received a bill of X $1,000 and how do you control it? First of all, you don't need to focus on the LLM itself. LLM is expensive, but if you think it in overall usage, it's not that much. Like if you want to use OpenAI endpoint to generate some, like to interface with some like small context, like even a classification, is this a cat or a dog? It will not cost much. If you give it to the agents, you need to have a certain control in terms of iterations, but there are some other techniques that you always need to have for enterprise level. That is, for example, cache or store informations within a memory, or having like agents that can communicate at the same time, can have the history of all the chats that have been done. So the only thing that you need to reduce is how dynamic context will behave, because that is where the LLM will change the answer. If you have the context that is, let's say, static for majority of the time, what change and what you're paying for is only the last part that is now getting modified. Like Maksym said, like the API on Confluence can change. But if you have like generate a Confluence page, create a child page, then create a Jira task, and only the Jira task API changed. All the rest, you don't need to go again and say like, okay, I found the Confluence. Okay, I found the Git. Okay, you don't need that. And here you can see that the cost drops not a lot more. And last but not least, that's always considered in our architectures, there should be always a way to compress the chat. That now there is this big boom of this TSON format, instead of passing JSON to pass, it will not last. Why people don't use CSV anymore in big data or in the data engineering anyway? There are too many limitations, but you can compress a huge JSON structure to make it cheaper from the input context. The other option, of course, is if you know that you're gonna make 15,000 requests per second, perhaps you can consider to self-host your open source model and scale and control the prices in a fixed manner. Max, you want to add something from your side?
Okay, yeah, I know a couple of life hacks if you like with the MCP especially. So if you have database with various tables and you're ask your AI agent, like coding agent, fetch some users with triple name, the double name, like, some people have double name or double last name. So, and what it does, it goes to one table. Okay, this is wrong table. That it goes to another table, and then checking, random tables and trying to guess which one is right. Yeah, so how to my life hack, how people doing pretty the same. So they just they're generating MD file that describes the database. So, and when you're asking your AI agent to use MCP to prepare SQL query for you, so you need to ask not only just generate the request, like generate some query, but use this MD file to figure out where it is actually. So, and in my experience, from 3 attempts, it goes to 1 attempt, and this attempt is right.
This one. Yes.
Oh, it's okay. Oh, it's okay. Thanks for your speech. I have a question like how you using your agents as a helper or it's independent worker who do the job and the job is proactive or reactive? Just imagine like I'm from operation background and just we have a server and it's a reach limit of the space. Yeah, we have a trigger and they add automatically like. But at the same time, sometimes it's too late. Do we have what kind of maturity level of your agent? They can allow them do themselves and proactively, like prognosis, diagnosis, or whatever future troubles, or it's still like a helper, like you said, like
okay, so it's like let me ask you a question before I give an answer. When you create a microservice, before all this boom of AI and agents, were you thinking that all the APIs were REST APIs, or there were also some scenarios where you say like, okay, maybe I make a Kafka application that react to a queue, or I can make an enterprise service bus that scatter and gather question answers. The same is for agents. We will show in the demo that some agents require an input because they are designed for multiple actions, but some others can be more independent. And that is exactly what you need to realize when you make agents. So if some of them can be mature enough to be autonomous, like an agent that perform pull request reviews on GitHub, that is something that can be potentially autonomous and be reactive. And another one that, for example, write the code cannot be fully autonomous, or cannot be that just like you create a folder, you give and they say, oh, I have a folder, I will create a random mobile application because that's how I've been designed. So the majority of agents are, first of all, not something that you say it works, we go to prod. You still need to keep consider it as a machine learning or a deep learning. So the methodologies of ML ops, they still need to be applied to LLM ops. So you still need to apply observability, monitoring, reinforcement, and so on. Like the MD file that Maksym mentioned, it's something that will make your agent moving from it works on my laptop to maybe I'm ready for Q&A from QA and so on. So even these small things can make the agent mature to at least be an assistant. Then if you want the autonomous, there, in my personal opinion, we are still far from it. But some people can prove me wrong.
Test. Okay. Yeah. So I wanted to ask if you had such cases in which one MCP call depends on the results from another one, and how do you deal with hallucinations if you had such cases?
Yes. So in one of the demo we show, we have an agent that does multiple MCPs. Like one read from code base, another one can generate Confluence pages, Jira tickets, and it needs also to retrieve what has been done before. The hallucination is something that can always happen. And here is important when you create agentic platforms to have this layer of observability that allow you to check afterwards, and the human needs to be involved if the agent is uncertain. So let me come back before to one slide that we went through before. Okay. So here, why I mentioned before, these two agent as a judge and agent meshes are important, because in this case, the agent as a judge can give a level of confidence, and the meshes is where everything is contained. So you can have tons of agent as a judge or agent guardrails that can potentially help you with this. then everything else should be anyway with the human. Like when Cloud Code asks, this is my plan. Are you agreeing, not agreeing? Give me some additional context. That is where the level of confidence needs to be checked.
Well, this looks like a partial solution. I'm wondering, would it make sense to move to a more imperative way of doing this? I mean, just get your tool calls or MCP calls, put them in Python code, and that way maybe you can manage. Well, in this case, I think you don't run into hallucinations that much. And yeah, what's your opinion on this?
That is exactly what he mentioned before in adapting MCP or not. In his demo, there are no MCPs because if you don't need this level of complexity in this decision making on the tool, make it procedural. I call Confluence, I call Git, I call microservice, and then I give you the answer. Perfect. It will work anyway. It still fulfill a need. It doesn't mean that now everything should be autonomous agent. So definitely in that case, you make sense of what you're saying.
Thank you. Thanks for the presentation.
Any additional questions? Yes. Yeah.
I have a question here. So in the last period, a lot of people are overusing the agents as agents. So there are a lot of tasks that can be done like tool functions, not agent as a tool used. So is there any formal list or some best practice of the market in which we can fairly decide, is it worth to be used agent as a tool to perform a task or writing a function tool, let's call it like crawling a website. Crawling a website is a tool that can be done easily in Python and it's fast and linear in terms of cost. Doing it as agent, it costs like 3-4 cents depending on the site size. And it takes much more time as an agent to crawl the site. Actually, are there a specific set of rules right now, market-wise, in which smart people says you do in this case so, another case so?
Yes and no. So similar to what I have said to the previous question, right? Or to approaches in general towards what decision you're taking. There are no written rules. And every organization will have completely different rules, even within their department. If you are talking more about like a sort of decision tree, it can be an agent, can be a simple RAG, can be no LLM at all. The only answer I can tell you is no, really. Like it can be that you need something that in one moment is purely deterministic, and then 1 month later you go with the agentic solution. And the only thing that can block you is how much are you lazy. And if you have to do some sort of like analysis on video clips or images and so on, if you are lazy, you go to Gemini or to OpenAI, you chop some scenes and you put it to OpenAI and say like, give me the answer. What's happening in this video? It will work. With some tuning, it will work. Exactly. The cost is much higher, but again, this is another rule that is variable. Who is gonna pay for this? Do you care who is gonna pay for this? And are they really caring that much about the cost? Because maybe the revenue of the investment, it's so high that why optimize what is not needed to be optimized?
Maybe the agent is in the background as well equal to an LLM, and the reply to that is the text or the context the LLM provides you back. So MCP is like a set of agents and set of like tools and context or resources that are like in a bounded context. And in this case, if we as people succeeded to formalize a simple question to an LLM, getting the answer into a framework, SDK, or MCP. So maybe there are already industry-wise standards from smart companies like Anthropic, Gemini, OpenAI. I didn't follow it, but I feel that there should be something where we as people, we as business owners might decide whether to use an LLM, to use a tool, to use an agent, or to use a mesh of agents in which you'll have a workflow of agents deciding a question answer.
Okay, so, and if you talk with Anthropic, OpenAI, they are trying to make tons of these integrations, right, already in their UI. So it means that this embedding the AI inside the application, it's a standard. So this is like a root standard. If you're considering about, you mentioned like when to use tools, not to use tools, technically is only about how much you want to make the agent autonomous, or even the LLM call, even if you, so that's it. Because if you, as I mentioned before, you need to do like always get one information, then get another, and then call the LLM, you don't need the tool. Just create your own prompt, make it dynamic, pass it to the LLM. If it's some rule, like golden rule about it, no. It's like saying like, are there any golden rules about writing microservices with Spring Boot? There are some guidelines, but there are no golden rules. The golden rules are up to the team leader of the project, the senior developer, or the company itself. So golden rules on this point of view, no. Although, of course, Anthropic, OpenAI, Google, they are trying to make their own product that follow their golden path. You can just adapt it or not, or make your own one.
Thank you.
Yeah, I just want to contribute to this topic. In my case, I prefer to use some scripting. Like I'm trying to avoid LLM as much as I can. But sometimes my VP goes for the coffee with other guys from Silicon Valley. They're drinking, they're discussing AI, and then my VP come in saying, "Okay, I want AI automate all the stuff like everybody have, and I also want to do the same." I'm saying, bro, this is like it would take a couple of months. And we need to involve 3 to 4 like data science engineers. And he said, okay, I'm okay with that. I'm saying like we will burn a lot of tokens of OpenAI. He said, I'm okay with that. I'm saying I can do it single, like, instead of 3 to 4 engineers, I can do it by my own for the same time. It's gonna be way cheaper. He said, no, they have AI. Smaller models creating smaller problems. Bigger, actually, even not smaller problems, but bigger problems. Yeah, let's go ahead.
Okay, so thank you a lot for your questions, guys. We didn't expect so many questions actually as a first Q&A session. So we continue now on our path, and I hope that will give also answers to some of the questions that have been made. So first of all, coming back to what I was mentioning before, why Pydantic AI? First of all, what we are doing here with our agency is understand the code base, creating, managing documentation. We use Confluence because I believe that Confluence is the most standard platform for this. Create Jira task, help our vibe coding or coding agent, in a coding agent support engineer, and then make how the multi-agent coordination works. So those are our business requirements. We need to deliver this, plus make everything autonomous, because the VP was at the coffee with their other colleagues and said, we want to have everything autonomous with some control in the middle. So why we use Pydantic here is we need the enforcement. We want to reduce hallucinations because, mentioned before your question, every tool can make higher the possibility of take the wrong decisions. Then we need the reliable integration with developer tools. Cursor, Cloud Code, this application should be a sort of standalone, yes, but at the same time, I want to integrate it. And at the end, Maksym will give a really deep dive on how you can have the test, not only the test, but validate and be more accurate on this point of view, and memory state, the MCP, and all the technical parts. Okay, so an eye overview. As explained, we have our agent mesh or agent canvas. There is GitHub, that this GitHub agent is also for some degree a coordinator agent. Everything passes through this one because in my use case, we use repositories. We are gonna show in a live code that we want to migrate one of the nightmares programming language of all, COBOL. Now, a lot of customers are trying to get rid of COBOL, but the youngest, maybe senior engineering COBOL you can find can be potentially our parents or grandparents in some case. And they want to, and they ask, of course, because they are so niche, 10 times the salary that you would give to anyone. Or if you want to use the most expensive LLM, still will be cheaper than a senior COBOL engineer anywhere in the world. Then there is Confluence, because it's a lot of an error that a lot of people do is that I want to migrate COBOL to JavaScript. I take my big 3,000, 30,000 lines of code COBOL that represents the whole banking system in the world, put it in OpenAI and say like, hey, convert it to TypeScript, make it cool, expose it, and put it on Cloudflare, so it will fail in 1 week. We don't need that. This is a mistake. We need to understand what the program does, because this code most probably is 60 years old and 80% of this code is not even used anymore. Jira, there is always Jira. Always. You will never get rid of ticket management systems. And at the end, you need to write the code. So this is an example workflow. Myself, I got assigned this COBOL migration. Obviously, I don't know COBOL. I never even took a look at the file. I know that there are different types. And I want to just pass it to my coordinator agent and say like, go through, generate me, configure a knowledge base out of this project. That can be really like huge. There are some mainframes in COBOL that are really massive. And no one in the world can read those mainframes and tell you 100% accuracy what this mainframe do. Then we create knowledge base. And this knowledge base is in Confluence. And on the back, we need a vector DB, as Maksym was showing in a chunking strategy that perform a sort of a knowledge base. Now, after you go through all the files, you can give rules. Like, for example, give a look first to the README file, then go to the memory file, then go through these folders and start to scan one by one, for example. Or you can just take your own decisions, go ahead. Then, after getting the context, you generate documentation, the agent can still ask questions. Maybe it's not certain and say like, I see this file that looks incomplete. What's supposed to be here? It can be configured in this way. There can be rules. And the other workflows are feedback loops. So this happen in an autonomous way, but this can be from a user. I will show you later in the demo. The same story can be applied to Jira. So it's still a Confluence agent, but what we do is just read through my knowledge base, perform checks, update, and so on. So this is like, I want to verify that documentation is done correctly. I tell that the agent make a mistake, some specific file. I add the details. I can do restructure. Actually, fun fact, we were doing it before starting the demo, our agent restructured completely our Confluence page. So his demo, yeah, my agent decided over the night to restructure the Confluence page. So all the links that his code had didn't work. Because after some checks, it's like, okay, let me rename this Confluence page overview instead of high overview. Everything changed. So here is where the human is needed. Second part, tickets. You don't write enterprise code without having the Scrum Master, the product owner, the product manager, the product owner, and so on and so forth. Because before taking the ticket, you need to assign it to you, mark it in progress, clarify with the business analyst if everything is fine, mark it as blocked if the business analyst doesn't reply you within 24 hours. So all of these things have to be done. And I'm pretty sure that no engineer or programmer is happy and enthusiastic to do that. So in a question that I got multiple times is, what would you automate first? The answer is always the same. What is the most tedious action you do during the day? Take care of Jira, take care of the emails, take care of the calendar. These three agents are the ones that I'm pretty sure that everyone needs in our nowadays world. And you need to give feedbacks in this case, because there will be an agent somewhere that will do the work for you maybe. So the knowledge base, our memory of the agent needs to be always up to date, and then the tickets must be always up to date. Last agent, this is something that you can apply. You decide to do it on your own, be my guest, but I believe that 90% of the people right now use Cursor, Cloud Code, Gemini, and so on. So here is where our agents can be integrated via MCP servers, can be just plain MCP servers integrated with our Cursor, or can be Cursor that call via MCP an agent that inside has other MCP that call agent, that call other MCPs, and so on. It still can be done and can happen. Okay, so little space for a demo. So, okay, it's visible, right? Okay, so this is how you could see an agent canvas. So now this one is via UI. Most of the times can be even a DB, can be just shown as nodes in a graph and so on. And here you have three of agents where one is an agent that is with the UI, so it needs to be invoked, and others are autonomous. So just to give an example of multiple agents, so let's go with this. So I don't know if someone is familiar with this UI. It's temporal. It's an orchestrator for durable execution for agents. Not gonna present any more in details about it, but I want to show. So this workflow represents an agent workflow that can be called via UI, via MCP, however, but inside you can see that I have my other agents that basically are my assistant. So it's a sort of a router, and these guys between themselves, they talk. How simple a messaging system. They send signal, they look for answers, and what I do is just sending a prompt, refresh the knowledge base of this project. And now I'm telling the other agents already know the targets. So don't ask me back. They know. So then what happened is just the agent go through And here you see that all the autonomous interaction goes, I see like 3 phases were completed. The final coordination go. Here is basically, this is the moment where Maksym demo got broken. So these phases, you see, you have phase 1, phase 2, phase 3, and then everything is getting refreshed. So here, what I'm asking to my agent is go to this repo, generate an overview of the project. Give me a quality, give me a rate, generate diagrams, make everything that will be useful as an overview. But then I need business logic, architecture, components, data contracts, integration, quality and risk, and engineering insights. In your opinion, by raising your hand, are these 8 topics enough to build a product and to make it, let's say, as a minimum presentable? Sorry? You don't have cookies? Okay, cookies and coffee, that makes sense. We don't need to add it. You're right. So in your opinion, in order to make a POC, these 8 chapters are enough? Exactly. So still I need a review. So here, this is an example. So you can have a really rich Confluence page, but at this phase, I don't know if my documentation is correct. So I'm the subject matter expert in this project, and I need to verify. How I verify? Now, the UI is for people that are not technical, because if you are technical, you can make an MCP, you can invoke an API, it will work anyway. But here, I want to say, please give me ZBank architecture. Now we can see from our orchestration, the agent is running. It is doing tons of things that we can check, like they are calling LLM tools, LLM, then tools, then other things. And here we can see that there is the thinking. So you can see all the progress is fetching my Confluence pages, is checking from the knowledge base. So after some time, we can check. So LLM calls, where it can be optimized this. Our agent, in my case, my agent are just returning every time are configured for the maximum output length possible. Because I wanted to have to use the same agent to generate everything and also to be queryable. Not a good choice, because as we can see, the call is still ongoing. And this is, by the way, where the application of temporal is useful, because this will never fail. Even if it fail, it will keep retrying without make the user know that his question is not going forward. But it finished. And here we go. So now I have all the informations about my ZBank architecture. It generates me an architecture pattern. It generates me the layers. Now, I have no clue what this COBOL application does, so I cannot check. But the idea is that if you have someone that is working in a bank, in this specific bank, let's say for 15 years, and it was the one that wrote that COBOL mainframe, he will know, or she will know for sure. So this is the first part where the human in the loop is important. Now, after that, I'm not gonna mess again with Maksym tests, but within Jira, I can create also the tickets. But I don't know. I'm not gonna do it, Maksym, no worries. And at the end, what happened is, so we have our code modernization agent. Here we have tons of tickets that have been created, because what I ask, take the ZBank project, migrate it to Java. So it will take a lot. It can take checks, tests, and it has to be anyway deployed somewhere. So all of these test tickets have to be done. How you do it? Easy, like how you do nowadays. You go on cursor. Let me just switch. You go on cursor or any of your coding agent. And then what you need to do is just go to your chat. I don't see, okay. And let me check if I have some. Okay. So what I ask here, identify my first Jira task regarding ZBank migration, assign it to yourself and implement it. Here we go. We have ZBank data, ZBank service, ZBank web, now the POM. So basically it's a Spring Boot application. Okay. So yeah, like you can see that what the agent is, it went on Jira via MCP, connected to Jira, assigned a ticket, and then it performed these 9 to-dos. Simple as it looks. The only challenge is you need to make the agent understand the rules. That were mentioned before, this MD file about where to find the tickets, for example. Maybe in case you assign a ticket in an organization that is not yours, or use, for example, MCP servers like Context 7. Context 7, for who is not aware, is an MCP server that connects directly to wikis and find always the most updated documentation for every framework. So if you want to migrate to Spring Boot, maybe you want to migrate it to the latest stable version of the library, and you don't want to rely fully on Claude or OpenAI that maybe were trained with data of 4 years ago or 3 years ago. So you want to use the newest frameworks, the new version, the most secure, and so on. Context 7, for example, can be set up as a rule. And now I will pass the word to Max.
Yeah, now someone have to test everything. These developers vibe coded. Yeah, so I not created the AI agents. I'm not gonna do this work even more complicated than it is. So let's go through the test case generation flow, what we actually do as quality assurance engineers. So we have a ticket. I hope you see it. So we have a ticket as an initial requirement. So, and you think we have to generate tests, right? And that's it. No. So before we generate some test cases, like test scenarios, we need to we have to do some clarification, requirement clarification. So we have to read the ticket, we have to validate all the requirements, we have to check if they're not contradict something. So we have to talk to business analysts. So a lot of work even before we generated some test scenarios. So yeah, and first we are clarifying all the gaps, all the questions that we still open that were not mentioned in Jira or Wiki or Confluence, so on. So, and then AI just asking a list of questions to just double check that everything correct, so on. So user provides the answers. We also goes to generation, test case generation, and you think that that's it finally. No, it's not. We have one more set of clarification questions usually, because AI may hallucinate. It may, we're testing it, like this is the part of our internal research and development project. We're selling to other clients. We have the blog posts about it. So and we're testing on our internal tool called staffing tool, and we're creating a job post, let's say like a senior data engineer, and AI, after the first of the test, if we will just generate tests here on this stage, it will generate some weird scenarios, like validate the salary range, but we do not have salary range anywhere. Like it's just, taking some internet data from the internet, maybe from the AI experience, AI more experience in job creation. So, and to validate this stuff, we just have another set of questions. So we are validating the temporary generated test cases against the requirements and double check that nothing like appeared like no job post, this salary range, so on. So then user have to answer those questions. And then we're just validating the coverage to be sure that we covered all the test requirements, providing the coverage, providing all the tests. So, but we have a lot of data like between this. So AI asked some questions, we replied once, we replied the second time. So not to lose this data provided by user, because it's not written, as I mentioned, it's not written in Jira, it's not written in the Confluence. So we may lose some important data. We have this documentation agent, like document creation agent or like document update agent. So this agent can find the appropriate Confluence page and update some particular some particular part of it. So in my case, let's say we changed some states from like interview preparation changed to in review. So I specified the proper answer here on the set of the answers and question by AI, because it can find the confusion, because in Jira it says in review, Confluence says interview preparation. So it just after that it can just update the documents. But I'm not gonna show you the document part, it was too complicated. Yeah, but if you check out our demo on the website, yeah, it's there. Yeah, and then we're pushing everything to Confluence. Let's deep dive actually what is the requirement clarification. So first we have to build the context. So we have as an input, we have a feature, like feature requirements. This is our Jira ticket usually, as we're using Jira. Then we're building the context. Context we're building based on VectorDB. We're getting all the data from VectorDB, collecting everything, and then generating the questions, and then user have to ask those questions. And I'll show you on the UI. It significantly improves the quality of the final test cases, as well as when we're using the hallucination detector. Yeah, and test case generation, I'm calling agent, but technically this is not an agent. We will see on the demo. This is just regular backend that calls the LLM. So no magic with the agents, no temporal, no. So we just, since we have requirements, we can generate test cases and then push them to some system. We use the test trail on this test trail on I displayed on the picture, but what we're talking, like we're showing this presentation to the clients, and sometimes they have different tools for test case management, like they're managing in Jira, so we can integrate with any. Literally on the backend, we just created some interface if a client has some weird test management system, or even like GitHub. I know that some people storing the test cases and the test scenarios in the GitHub. We can push to GitHub, whatever. Yeah, let's move closer to the demo. Thank you. This is my Zoom. Yeah. Yeah, Simon already generated some pages and tickets. So we will test one of those tickets. I'll take the first. I generated some small UI for you, just make it everything simple. So we have this test case generation agent, and I'm typing the ID, but the most interesting part we will see in the console. Yeah, 404, it's okay. It's
Test failed successful.
Yeah, test failed successful. Yeah, let's see, like it will send some request. We will see it here. Yeah, so I'll recreate the VectorDB, but usually we're not doing this like that. So all the time we're not creating VectorDB from the scratch, but for the demo purpose, I'm creating it from the scratch to show you the stuff. One important stuff, this is the embedding model. So to put your since you already have some kind of chunks, you have these documents that you want to load to VectorDB, you need to use embedding model. This is local model. You can install on your MacBook if you have MacBook, or like PC, whatever. You can install it locally, and then even you can generate some answers based on I don't know, local models, which is right now is best.
Fine.
Yeah, like you can use local models, but they have really small context windows, so most probably not gonna have an answer. So that's why I'm using the GPT model. Okay, we're loading everything to vector database, and we need to, as I said, the first part, this is the query. So we have a query. So the query is my Jira ticket. So I'm using Jira ticket as a query to find all the vectors related to the all the vectors related to this topic. So because in VectorDB we're searching not according not by the keywords, not by not by the text. We're searching by the this is semantic search call. This is by the meaning. So if it's this about the job post, we will find about the job post. Doesn't matter if it contains word job and post. Yeah, and as a result, from the VectorDB, where from the VectorDB, VectorDB returns us chunks, as I mentioned. I hope you can see it. So this first chunk was the 53% match. 53 is pretty low amount. It's really low because yeah, the documentation could be better, I'd say. And Jira ticket could be better. So if documentation better and Jira ticket better, so you see. So you can configure actually, yeah, what I planned to show you also. I'm searching for 10 chunks. And also I plan to show you the size of my chunks. Yeah, I have chunk of 512 characters, and also I have overlap. So not to use the context chunks, not to have, instead of 10 chunks, if I'll add context chunk at one before and one after, it would be 30 chunks. This is huge amount of text. So I'm using the overlap. So I'm just getting the 50 characters before and 50 after. So yeah, let's go next. We found some chunks. Then we need to build the prompt. So we're building prompt. Let's check. Okay, it's there. Let's go next. Yeah, so we are building the prompt together with. So I'm taking the Jira ticket. I'm taking the documents from the chunk. This is actually it is the prompt. You're senior business analyst. You have to do the stuff. So just some generic stuff. It really depends how you're describing your prompt, the format of the prompt. We're not gonna touch it. So it goes the Jira ticket. I'll show you maybe in the cursor later. Yeah, so this is Jira ticket, and then we have this related documents from RAG. And then I'm just attaching this all the documents, all the chunks from the VectorDB. Also, I'm specifying the link to actually the document where we got this chunk. So as I mentioned, in the metadata, we can add a lot of interesting information. So I'm using source. So this is the documents, and then as a result, yeah, also I'm specifying what the output format. It's very convenient because if it's already replying me with the JSON, I can use this JSON to return from the backend directly to UI. And what actually happened? Yeah, I'll just zoom in. So yeah, here on this stage, we're trying to clarify the questions. It was interesting question here. What algorithm should be used to store, verify, blah blah? So it found that some Confluence pages they contradict the Jira ticket. So you have to specify what is the right source of truth, what is the right answer. So I'll just click some random. So yeah, because our requirements not really clear, and our Jira ticket, it's mostly the story. You have to break down the story to the task. So that's why it contains high level description. That's why a lot of details are missed. So we need to as you see, it suggested AI. Imagine I know the proper, I know the options, I can suggest a couple of them. So yeah, that's why we see so many. I'll use the Confluence. And this is how it works in production. Also, I'm just giving the ticket. If we do not have any proper option from the Confluence or Jira, we just it's just guessing. But anyway, anytime I can specify. Oh, perfect UI. This is I did.
He's the first QA that is more accepting the things made by engineers than himself.
Yeah.
So
Yeah, so I'm specifying the answer. Yeah, we also we have the option other, so user can specify some custom answer if the user don't like, because we're quality assurance engineers. Yeah, I'll submit. Yeah, here it should be verification questions. We're calling this hallucination detector. So like how we're doing in production, we're just generating temporary test cases. We're not showing to user. And then we're just calling one more call to LLM and comparing our test cases against the requirements. And here we find like a lot of interesting stuff that, AI hallucinated, and we just, specifying like the proper answer. Yeah, it may ask the same question like in clarification questions. We're fighting with it. And especially what I want to highlight, different models generating different set of questions, OpenAI, Anthropic, Gemini. So, and as we have pretty big Confluence pages, we moved to GPT models, to OpenAI models, because they have the biggest context window. Anthropic, they failed maybe
250, I think.
Yeah, we tried Anthropic, and in maybe a couple of hours of testing, we decided, okay, we're not going to with Anthropic. We moved to Gemini. Gemini also, and all the time for each particular model, you have to change your prompt. Different model, different prompt. Yeah, I'll start generating test cases. Yeah, so this is the instruction. This is the how clarification question look like. So it just specifying me text, like the question and option. So this option related to this particular wiki page that thanks to Simon regenerated. So because, in advance, I saved all the wiki pages to CSV file.
Trust is good or no trust is better, no?
Yeah. So yeah, this is our clarification questions. Let's scroll. Yeah, we're for the test case generation, for the clarification, we're using the GPT-5. Like again, this is just regular backend. Yeah, we're just pushing everything all together. I'll show you the actually original prompt. This is not the clarification question. One quick second, I hope you can see something. Yeah, test case generation. So you see, for the test case generation, I have Jira ticket. I have clarification answers. We will see it in the prompt as well. Related documents. So whatever we got from the first stage, so we're generating context only once. So we only once calling the vector DB, collecting all the documents, and then we're just using it, just storing somewhere in the memory. Of course, you can store somewhere in the radius. I prefer just regular variable in Python. I'm sorry for that. Okay, yeah, and just specifying your task, what should be done by AI, by LLM, and then as well, like as before, I'm just specifying the format. I'm so lazy, so I'm just specifying the format, and latest models, they're following the format, really good. Maybe if you try GPT-4, maybe not. Like, but GPT-5, 4.1, reasoning models, they're following the format and everything. Usually it works good. Let's see, generation takes time. Let's see the console. Yeah, so yeah, the question and answers here. So this is just, we saw the template. This is the answers that I provided on the previous step. So our work, it can like the two steps, right? As I mentioned, this is refining the requirements and then already generating test cases. Yeah, documents. Oh, okay, this is test cases. Okay, we see the generated test cases. This is actually UI from the production. I can click on the, also we need the human in the loop. We don't have this, select all. Actually the Q quality engineers from our internal project and work with the 5 project, they asked about this button. I said, no, you will read every test case. You will read every test case. Yeah. So, and we're trying to prioritize. Actually, specifying in the prompt, we're prioritizing. We're trying to guess what is the technique. Quality engineers, we have techniques. We're not random tests. Yeah, we have a techniques. So we're using these techniques to create the tests. We have a precondition steps. So format also could be adjustable. So if the client wants, I want BDD. If you know what is BDD, this is given Van Zandt, like when we're describing in the Gherkin format.
Oh.
So yeah, we can do that. Just a couple of fixes in the prompt and that's it. Yeah, I also allow our quality engineers, to edit this test case. Like they can edit how they want. They're specifying, yeah, and I don't have any connection right now to, of course, coverage 100%. I trust LLM, you know. Yeah, anyway, we have this human in the loop all the time, quality engineer, you know, all the time. It's, you know, to be a quality engineer, it's really hard because you have to be all the time smarter than AI just to survive. You know, you have to all the time you have to be, you know, one step ahead than AI. Yeah, and in the end, I allow our to load our test cases to the test trail. As I mentioned, it could be Jira, it could be GitHub. So, but yeah, I not implemented this part in my demo. I think that's all interesting stuff that I plan to share with you. Let's see what we have. Yeah, that was the demo. Okay, Q&A. Guys, feel free to ask the questions. Yeah, just raise the hand.
Do you use different model for planning, for creating tickets, documentation, and different for coding? Because I know Anthropic use within Cloud Code. They use Opus for planning and Sonnet for coding. So do you use those for, let's say, making cheaper cost? And yes, how you choose the right model? Because we are different benchmark. Maybe you just like agent tool calling, like how good is the benchmark on just the model, or you use different, I know, context window, how good is perceiving, all the stuff.
Yeah, in my case, yeah, we are dreaming. I'm promising to my product owner that I'll change the models. Like I'll use different models for different cases. But for now, to be honest, we have a budget. I don't see any reason to use some cheaper models if I can use some expensive models. But yeah, this is in our roadmap. And how we prefer, we're not checking the benchmarks. Our best benchmark, this is my senior QE. So I'm just asking data science guy, could you please let's try another model. Let's move from, actually we moved from O3 model to GPT-5 right now, but before that we moved to 4.1 mini or nano, something like that. So because with model O, like a reasoning model, all the end-to-end took 11 minutes, and 11 minutes, my quality engineer sitting like this and waiting until everything done. So yeah, and it was boring. And my product owner said this is too much. You have to find something. So, and then we were just training. They're doing 3 to 5 cycles. Data science engineer just providing 3 to 5 results from first validated by data science guy, and then giving the best result to quality engineer. And quality engineer already deciding, I have human who are deciding what is better. Any other questions?
Hello, it works. Guys, any idea about the costs and the return of the investment?
Okay, in my case, it's really complicated because a different model, different price. So O3 end-to-end was test case generation. It was kind of 20 tests and with updating 2 documents to wiki pages. It's actually pretty complicated to update wiki page. That's why I'm not showing you this demo part, because wiki page usually it's huge. And AI, it's really hard to explain. AI, please change only one line of the text. AI wants to change everything. Only these models, latest models, GPT-5, it does whatever you ask. But GPT-4, just you're asking, please change the name of the document. It will change everything. It found some issues. It will change everything you want. So it depends on the size of the document. With O3 model, it was $1 per generation was the documents and the tests. And right now we're using the 4.1 Nano. I'm not remember Nano or Mini. It's extremely fast and extremely cheap. So I guess maybe 10 cents or even less. Boss.
Let me share my screen quickly. So as one important thing to consider for, I think go like this. Important.
It looks expensive.
So revenue over investment. That is exactly how much it costed us. It costed me to generate documentation, Jira tasks, and the code based on what Maksym just tested. So this looks a lot, but how much it would cost a business analyst, a COBOL expert, and a product owner for a project that is relatively small compare with this price. So first of all, when it comes to agentic platforms, you always need to have an observability tool, because if a person that is not technical will ask you these questions, you need to be ready. You need to go and say like, I spin up my GPT-5.1 on Azure, I have now something free, so I'm paying 0. Regarding also the question about which one you choose. GPT-1 for some points, Claude for everything else. Yesterday, we had to change some parts of the demo because we were running on Gemini Studio API, and we just found out that in Moldova was not available. So, so we needed to reroute a lot of APIs to work with either Gemini or either GPT. Like classic midnight fix in production, works on my laptop, let's push forward. Exactly does it happen. And in this case, then you can have prompts, engineering, versioning, and then you pick basically the one that you have. But yeah, that is really important. For ROI, it depends on the business that you're trying to make. In this case, I think the value that you're getting is quite a lot.
Yeah. Sorry, again, question about cost optimization. Oh, yeah, okay. So we have, like, for example, agentic application, basically AI plugin that we can use for publisher websites, and it works like really good. Everybody's talked. Now we need to basically to scale our solution at least to like 10,000 requests per day. And we started to figure it out, okay, what are our costs? And it's like 50, 100 times more than we can afford. So of course we can do a lot of optimization, but I wanted to ask, do you guys know maybe if there are some best practices how to do it? Because obviously we can take cheaper models, we can host maybe something by ourselves, maybe we can, I don't know, split logic, replace LLM calls at all, reduce context. Do you know maybe guys some best practices like that we can use? Thank you.
Yeah, there was a similar question before about that. First thing that I would say, like, cache answers, like cache as much as you can. Like sometimes there was a video I saw that was like cache like there is no tomorrow, right? So it's safe. Like, don't use your own, especially if it's an organization that you're working with that have their own data, and the data that is getting sent is proprietary data. There are tons of libraries, tools, integrations that will allow you to integrate well with that. Context length is important, especially the output token. That is where your credit card will get spilled. So if you want to have a more concise answer, make your prompt to say that you want a concise answer and limit the token as much as you can. And the other point is loop. You have to make several iterations of your application before saying like, okay, now it's ready for production. We had the scenario in one of our clients where it was working so good, but then when we were having production, they could not handle 5,000 requests concurrently. Why? Because LLM was going down. They had to increase the tokens. The memory was overloaded, and some transactions were getting generated with the same ID. And at the end, what happened that the agent was going in loop all the time until it's like, okay, I reached my maximum attempts that were 100. Means that the agent went in loop for at least 85 iterations that you paid without receiving no results, when you could have just like solved it times earlier. There was a question there, yeah.
Hi.
Yeah.
Oh, did you hear me before? So thank you very much for this nice presentation. I would like to ask a question about the flexibility of the system. So how do you think, how much effort it will take in order to switch to another system? So for example, let's say we have another feature, newer feature actually on Anthropic or on some other open APIs that we have in the market. And how much effort will, how I understand that this could be as a draft implementation. So this actually from the beginning are like dirty code, something hard coded. But how do you think about general one? Let's say having some complex one, and how much effort would like to switch between them or using them together?
Yeah, okay, I'm replying how complicated to switch between models. So usually we're using some libraries, kind of LangChain. So it's easy, like, you know, in the background, it's easy to swap. So you have connector to OpenAI, you have connector to Anthropic, you're just switching the connector and that's it. But, you know, and then like work starts only there because you change the model, then this model replies you in another way. It's always like, in my case, it's always about the testing. We need to test all the time. Like, we're not changing the prompt dramatically, not like that, but we need to, you know, adjust a little bit, maybe specify examples for some models there. They work good with the examples. We need to specify how we want to reply, like not only the structure of the JSON, but with the example. Then
So yes, so you need not to train, but so there are like techniques that are like available on web about these approaches. Like, for example, to use Markdown, as you can see from the terminal, in Maksym demo. Markdown is considered one of the best way to interact with the LLMs because it's structured, but at the same time it allows you to have flexibility. So when the example I mentioned before, the case, I have to move from Gemini to Claude for the demo. I didn't change my prompt because I have Markdown. It was pretty straightforward, like saying like what kind of actions you need to do in some scenarios. In that case, the system is flexible. Just change the router. If it's about models and you're using the same API, it's really a string, but it's pretty common scenario to have in organizations frameworks or libraries or proxies that allow you to switch easier, like for example OpenRouter or proxy servers like Pydantic or LiteLLM, that basically you just need to change. You have one endpoint always, and you change the string or configurations and so on. So from this perspective, you have prompt and the endpoint that is really easy and flexible to change.
yeah, regarding the templates, how we're prompting, yeah, I'm using Markdown. Yeah, I'm not mentioned yet, but we're using Markdown, and but we really tested. We tried various formats how we can prompt the system, just starting from just regular string, then another. Yeah, XML. We tried actually we tried JSON and we tried HTML, and we really compared. This is actually the same prompt but different structure, like Markdown and HTML, pretty the same, but the result is like not the same. So we were trying to get the best test cases like we can. To improve. Yeah, how many iterations we need to get the better result. So we're doing actually 3 to 5. I'm dreaming about the automation. I'm dreaming to have some tool that will assess the quality of the test cases, automatically. But right now I have automated engineer, and he does this manually. So usually we are doing 3 to 5. 3 to 5 tests with different. Sometimes it's data science guys, they're checking by their own. If they see the good result, they're just giving us a couple of the attempts with different format, and and we're making decision what is the solution, because we're the decision makers, the quality engineers in my case.
It's working, right? So I wanted to ask, what is the biggest challenge in the current workflow that you are working with?
I will take that. So first of all is related also to the iterations that you have to do to make sure that you find the proper prompt. So in my case, for example, the biggest issue was to be sure that all the agents communicate in a way that can understand each other. So if I'm telling that my GitHub agent has to talk with Confluence in a specific way, like for example, he has to pass all the content before getting pushed or refined by the Confluence agent, I need to find a way to tell if you're sending messages to Confluence agent, be sure that this, and this. So it's like when you're mentoring a person that is more junior than you on something, in any job, not only ours, right? You need to give proper instructions. So that is one of the most complex thing. Second of all is the infrastructure. You have too many options now on the market. Everyone claims to be the leader. No one is actually the perfect fit. At the end, it's always a combination of multiple fits. And that is where actually your platform might differ from one to another. I don't know, if Maksym prefers to use LangChain for his program, but I hate Lang except LangFuse frameworks, I have to accept for his project this, but somehow I have to make my architecture work with his architecture for test. Or, for example, in the demo was visible, I use Qdrant VectorDB, but he's using Chroma because he's like wanted something quick that needed on the laptop and so on. So the difficulty now is to change which of these small shades in your architecture you want to do. And then you need the prompt engineering expert, basically a person that knows how to speak properly English. So don't hire people from UK, joking. And then let them do the prompt. Most of the time it's a subject matter expert. But it's fine.
Yeah, I'll share my challenges. You know, we started my project. I thought we will do everything. Yeah, we planned. When they invited me to the research and development project, they gave me 4 projects: so test case generation, automation, what else? The tool that AI that analyzes the logs of the automation tests and can guess what was the issue and group those test cases together, and some other projects. So I don't remember. So, and we stuck for 3 months only with the test case generation, and we started exactly with this. So we said, okay, we have a context, and we have Jira, we have the context from this VectorDB, and let's do test one shot. Then we found like, okay, it's pretty good, but maybe not. What we can do else? Like we thought, okay, what we can do is how it works. We're requirement clarification. Okay, we're adding requirement clarification, answering the questions, everything good, but still not, this salary range appeared. Okay, salary range appeared. We thought like, okay, we will give the internal tools that it would work like that, but no, our product owner stopped us, and we got another iteration of the questions. So in my case, the challenge was exactly to build the pipeline. We started like, okay, what I'm doing like a QA? What is my job? What like in the end of the and this document update, it appeared like, okay, I'm done. I'm like I refined the story. I know the proper answers. Why not to update the documents? Like, because this is part of my job as QA. I have to go and update documents. So in my case, that was hard to develop this pipeline, how it works. Because in one shot, not all you're not getting the best result in the one shot. Or sometimes 2 to 3, so on.
I have a question for your ZBank scenario. You, for example, just a generic company was invited to rewrite COBOL to Java, correct? Yeah. And my question, like, if you have code, but no specialist who knows this code, yeah, you generate documentation from this code, and later from this synthetic documentation, you rewrite new code.
Yes, but there are so many steps in between that have been skipped. So you take the code, you generate the documentation. This documentation must be reviewed by an expert. That can be from the client side or can be from the company side, the vendor, but still needs to be reviewed.
Yeah, because you have to know business logic of
Exactly.
this product, I should say. Generally, it's a lot of, but only after people or manual review you will do, or it's automatic steps.
It's all about giving a green light. Like, for example, in the test cases, you first clarify some questions, then you generate the test case, and then perhaps you create a ticket in Jira for doing it, right? The same is for all the part on the left side. So you still create documentation, then you have a person validate, give a green light. Then the agent, the Jira agent that can be reactive, is waiting for this option. Or I can go directly in the UI as I showed and say like, generate me a ticket, series of ticket of migrating Java to COBOL. After that, still there is a human that needs to be involved for verifying that. So this is why actually our presentation is called how we co-work with that, because still it doesn't mean that now we are taking our knowledge, we put it in the agent, and then we create asksmaksym.com. It will not be like that. Actually, it could be a good idea. But yeah, the idea is that we basically have one part that accelerate our work and the other that is done by us or by who is the responsible for that task. So all these pieces in between are always required.
And you use, sorry. And we're using like a source of truth, like it's GitHub or whatever source, and your synthetic documentation, or people, we have a person who will approve everything. Like how you can trust, like who will be responsible, like in guilty games.
So that's another point where we decided to keep the person behind, like Cursor, for example, or Cloud Code. So one of these vibe coding platforms, instead of making the agent fully autonomous in creating it, because you, at the end of the day, you need to blame someone, right? The client will blame you if you don't deliver the code. The manager will blame the team leader. The team leader will blame the developer will blame the tester will blame the business analyst, and then everything will go in circle. So if you make everything autonomous, you basically have only the LLM to blame, and no one will believe you that is the LLM approach fault. So that's why you create, yes, GitHub as a ground in truth, the documentation as a ground in truth, but then is the person there that before clicking git commit and push has to take the responsibility. Then other things can be automated, but the code still requires a lot of check. Otherwise, you will land in, as you can see now from the graph of GitHub, that 85% of the code is AI generated. And none of those code most probably are going to production because they are not stable. When they arrive the QA and start to run the running test, and we'll see like 15% coverage and 5% success, that code will not go anywhere.
Yeah, that's why I think like QA test, it's more simple because it's small. But if you rewrite whole application, like how you can trust them?
Yeah, and you don't create the application one step and that's it. So the idea of having the agent is that first of all, you can create multiple copies of these agents. It was a question before about the scalability. The agent is scalable. So you can create, like when you want to make a new project, you have to hire like 3 engineers, 3 testers, 2 analysts, and so on. The same thing can be for your agents. And that is where you make one agent that is assigned to task 1, 2, 3, the other one to MK 2422, and so on and so forth. And in this way, you basically have multiple iterations, code, push, test, push, code, and so on. You can even have the agent now on GitHub, for example, or on Jenkins or Terraform that make a CI/CD pipeline, but only after the tests are complete. So the software development lifecycle can be achieved with agents, but not with only agents. Okay. I think was
Give the microphone.
Share context between the agent type of your pipe, because generally you would need to. Do you have a shared context between the agent inside of your pipe? Because you mentioned that you use a vector DB which stores some data and you fulfill it, or every single agent has its own storage. And if you have a shared one, there is a limitation on each model with the context. Do you have some technique to restore this context, or have free context where you switch between them to get the proper result?
Okay, I can take it. There are, in my presentation about the verticals, there was agent memory. It's one of the technique where you need to have informations about agent context in scope of a run, or agent memory across different runs, or one especially for that specific user. So like memory of your interactions, or memory of your actions, or memory of your pipeline. So how do you share the context between agents? Is basically you give access to the same, let's say, block of memory. And this memory can be accessed even 1 month later or 10 months later. That can be stored in a vector DB, or can be a knowledge graph, or you can have the short-term, really short-term memory that is basically the prompt that is getting sent from agent to agent. Like if you use A2A protocol, they just communicate like you would do with your teammate, for example. Like send a message on Slack, wait for the answer. Same story. Or you can just use memory. And I store what I did right now, like you would do on Jira. You go at the end of the day, you go on the ticket, you write, this part is done, this part is done, this part is blocked, this part is, I will do it tomorrow. So then the day after, your teammate go there and say like, oh, this guy is out of office today. Let's see what he put in the logs. I will take it from here. So that's how about these things, about the context, how you can share it, think like how you would do it in the reality.
My question was a little bit like, if you, for example, have some history and you need it for processing, do you make some small procedures and don't load all this data to make the final decision? So you split it in chunks manually, not provided to the AI itself. Because usually if you would like just to load everything from Jira, it will fulfill context and it will even forget the request you send it to it. So you have to make some technique to split it into chunks, go to one chunks, proceed it, decide which information is useful, and so on. And if you keep all of that into vector DB, it's even more data. So how for each specific agent you solved that particular task?
You don't store in the memory everything, especially if your data is stored somewhere else. So your data is in Confluence. In Maksym case, for the fetching the test, he just only needs the URL. And you can store everything in the vector DB, but you technically don't need that. So there are cases where with GitHub, for example, GitHub MCP, you don't need to ingest all the code in the vector DB. You can have it even in close of a session, like with ChromaDB, and just take it from the run, do the similarity search in that session, and then tear it down. It's still on GitHub, but you don't make the context full as you were afraid of.
Yeah, but how did you say to agent, hey, don't analyze every single file into, yeah, you need to know it all to get the general overview of the project, but not to learn every single file. Like, yeah, you got something, but stop here, don't learn anything new right now for that particular.
It's always you that write the code of the agent. So when you write the code of the agent, you can define how much you want the context window to be.
Yeah, also in my case, I'm not using the agent because, for me, it's straightforward process to create the test case. So I'm just, I have some kind of orchestrator on the backend side. So I'm just calling the one LLM, I'm calling another call of LLM. I can save something in between, just to regular Python variable, and that's it. Yeah, and we do have like kind of this, our agents still kind of small backends, but we're deploying there to Docker. And I know that this agent can only fetch Jira ticket and that's it. You know, that you're just limiting the scope, what they can do, and you're limiting the scope, what they like, what the accesses they have. So this is one of the points why it's better to use agents, because you know, you're not providing all the access to one single agent.
Okay, and let's have the last question here.
Thank you. Thank you again. And the last question would be like, how you are working with switching the context during the working with AI. So for example, you are writing something and you see that it is going on wrong directions and you'd like to correct them. So first, I have seen that there's a great way in the presentation that when you ask the users, like to specify which with radial buttons or checkboxes, which direction it needs to go. Are there another ways that you are managing in your system?
This is when we're generating some code, or like in
we're generating code. Yeah.
Yeah. So you know, sometimes when if you're using the Cursor AI, probably you saw you asking to change one file and it changed 3 files to 5 files, and then you're just going back to that step when you're asking to do that in one file. You're saying, please do not touch this file, and you know, you're becoming very rude to the AI. Like you're specifying better model, you're specifying another, you're just literally shouting to AI, do not touch this file. And you know, it's still touching and you're almost crying. Yeah, guys, there is solution for this. First, ask to make a plan. Just you have some chat history, so the model already with the half of the context full, it's still touching the files that you don't like. Just ask to prepare the plan, and then yeah, and then it's prepared. Yeah, you're reviewing. So I'm asking to, like, I'm creating the folder with the like features or something like that. I'm asking like, please create the separate MD file with this particular folder for this particular feature with the plan. And then I'm just reviewing the plan. I'm removing everything that I don't need. And then, okay, go and implement everything according to the plan. And, you know, in most cases, it works. Oh, I see. No smell of pizza.
Okay, thank you very much. Thank you for sharing your experience, and also thank you for answering a lot of questions. I'm sure there are more to come during the networking session, but please let them eat first, right? And then we can chat and ask more questions. So let's move to the networking part until the food is warm. And thank you everyone for coming here to Grid Dynamic office. And thanks once again for the Grid Dynamic team for organizing this event. Thank you.